So we are reviewing guide 1-2, box A. The first thing we're going to look at is exponents. So just some generalizations about exponents. So the first thing we need to recall is negative exponents. Remember, negative exponents is just the exponential way of representing a fraction. So as soon as you see a negative exponent, that's the first thing you should deal with. That negative exponent tells you to flip the base. So remember, the base here is A, and every whole number is over the number 1. So when I flip it, it becomes 1 over A. And it's very important that when you flip the base, you put brackets around it. And then you write the corresponding positive exponent. So if you have a fractional base, same thing, you look at the base is A over B. The negative exponent tells you to flip the base, put brackets around it for the corresponding positive exponent. Any questions on that? Okay. The next thing is rational exponents. So rational exponents, rational just means fractions, right? So rational exponents is the exponential way of representing radicals. So when I have a to the 1 over n, that means the nth root of a. So the most common one we're going to deal with is 1/2. So any base to the 1/2 means the square root of a. But since the square root is so ubiquitous in math, we don't put the little 2 there. We're used to seeing that, and the 2 is understood to be there. But any other fractional exponent, you'd have to account for the denominator. So a to the 1/3 means the cubed root of a, and so on and so on. Any questions on that? So a quick little example of evaluating. Evaluate okay, so when you see a question like this, the base is 8, the exponent is -4/3. So you kind of want to dissect the exponent and do it in parts. Okay, so first thing you're going to deal with is the negative, then you're going to deal with the fraction, and then you're going to deal with the numerator. So the negative tells me to flip the base, so instead of 8, it becomes 1 over 8. To the corresponding positive exponent. The next thing I'm going to deal with is the denominator of the exponent, which is a 3. So that tells me to take the cubed root of the base. So the cubed root of 1 is 1, because 1 times 1 times 1 is 1, and most scientific calculators have a cubed root button on it. And the cubed root of 8 is 2, because 2 times 2 times 2 is equal to 8. Any questions on what I'm talking about? Okay. So I've used the denominator part, so that's gone. The only thing I'm left with now is the numerator part of the exponent. And that means 1 to the power 4, which is 1, and 2 to the power 4, which is 6. Any questions on any other, because that's all I'm going to do for exponents. Anything other trip you up? Okay. The next thing I'm going to deal with is radicals. So just a review of simplifying radicals. So whenever you see a radical, okay, in a mathematical expression, it has to be simplified. Just like fractions always have to be written in lowest terms, radicals always have to be written in lowest terms. So when you're simplifying a radical, what you're looking for is the biggest perfect square that'll go into that radical. So remember, perfect squares are numbers in which you take the square root, you get a whole number. So 1, 4, 9, 16, 25, 36, 49, and so on. So those are all perfect squares because the square roots of those numbers are whole numbers. So you look for the biggest one of those that'll go into 40. That's obviously 4. So what I'm going to do is I'm going to change the square root of 40 into the square root of 4 times 10. And one of the mathematical properties that we're using here is that when you multiply radicals, so the square root of a b can be written as the square root of a multiplied by the square root of b. So I'm going to change this into root 4 times root 10. And the whole reason that we choose a perfect square is because we can actually figure out what the square root of 4 is. It's equal to t. So square root of 40 is the exact same thing as 2 root 10. Now this stuff here, this stuff in the middle, you don't have to show. I'm just doing that for the benefit of the notes so you can follow along where I got that answer from. Okay? So simplifying, if you can go from here to here, awesome. If you can't, it might be beneficial to put in that extra work. And that's true for everything we do in this class. If you're able to skip some steps, and I understand it makes sense, that's fine. But if you don't, and you're going to make silly mistakes, then just take that little bit of effort and write everything down. Okay? Okay. Next example. So now we're dealing with simplifying mixed radicals. So mixed radicals have a radical part and have a number up front. It's the same idea though. What you're looking for is the biggest perfect square that'll go into 27 and the biggest perfect square that'll go into 48 to simplify. I'm going to write down everything so that you can see the process and you don't miss anything when you're looking and copying down the notes. Okay, so the square root of 27, the biggest perfect square that'll go in there is 9. So I'm going to change the square root of 27 into the square root of 9 times the square root of 3 plus 5 times the square root of 48. The biggest one that'll go into 48 is 16. So I'm going to change that to root 16. And again, 16 times 3 is 48. Now I'm going to simplify. The square root of 9 is equal to 3. Root 3 is not a nice number, so we leave it as a radical. Square root of 16 is 4. Once again, root 3 is not a nice number, so we leave it as a radical. 3 times 3 is 9. So I have 9 root 3. And 5 times 4 is 20. 20 root 3. And since I have like terms, just like algebraic terms, you can add x's, you can add y's together. I have 9 of these root 3's plus 20 of them. That means I have a total of 29 of them. Any questions on that? Sticking with radicals, but we are going to move on to rationalize. And in particular, you're going to be asked to, in this course, rationalize the denominator. Okay? And if you're going on to any other higher mathematics, you can rationalize the numerator as well. The only thing rationalize means is you want to get rid of the radicals on the top or the bottom. In this case, we're going to do the denominator. So, example, rationalize the denominator. And in order to rationalize the denominator, we're going to use the fact that if I have the square root of a multiplied by the square root of a, so looking at what we did here, square root of a times the square root of b becomes the square root of a times b. So this will become the square root of a times a, which is a squared. And what times what gives you a squared? That would be a. Make sense? Okay. So Rationalizing the denominator is I want to get rid of that root 5 in the bottom. I don't care if there's roots on the top, and in fact it will end up with roots on the top. The only thing you care about is not having it at the bottom. So you want to get rid of this root 5, so what you're going to do is multiply it by root 5. But everything in math has to make sense, right? You just can't change that denominator without changing the top. So if I multiply the bottom by root 5, I better multiply the top by root 5. Because root 5 over root 5 is essentially 1. So I'm multiplying this by 1. I'm not changing the value. I'm just changing the look. Make sense? Okay. So 3 times root 5 is 3 root 5. And root 5 times root 5 becomes the square root of 25, which is 5. So we've rationalized the denominator. Nothing too exciting about it. The only thing is now we don't have a radical on the bottom. Rationalizing becomes a little bit more difficult when you have a binomial on the bottom. So something like, say, 3 minus the square root of 5 over root 3 plus root 7. So just like when we had a monomial means a single term. To get rid of the radical, we multiplied it by the same radical. When we have a binomial, we are going to have to use conjugate radicals. So conjugate radicals, if I have the square root of a plus the square root of b, and I want to multiply this by something that's going to get rid of the radical. The conjugate to this radical is the exact same thing, whatever's there, which is that, but you have to change the sign in the middle. Because if you change the sign in the middle, what's going to happen is the radical parts will always cancel out. Okay, so let's just multiply this out, and then we'll do our example up here. So the square root of a times the square root of a, we know now is a. The square root of a multiplied by negative root b is negative square root of ab. Square root of b times a is the square root of b times a, or a times b. Doesn't matter the order. And then negative square root of b times square root of b is. So what happens conveniently, it'll happen all the time because the conjugates and the signs are different, is this term and this term are the exact same term with different signs. They cancel out, and I don't have any more radicals. So we're going to use that in order to help us get rid of the square root of 3 and the square root of 7. So I am going to again multiply by the conjugate. I do it to the bottom, I have to do it to the top. Not changing the value of anything, just changing the look of it. Okay, so multiplying out. On the top, we're FOILing out, right? So this is in brackets, this is in bracket. 3 times the square root of 3 is 3 root 3. 3 times negative root 7 is 3 root 7. Negative root 5 times root 3 is negative root 15. And negative square root of 5 times the square root of 7 is the square root of 3. Make sense? And on the bottom, root 3 times root 3 is 3. I'll just write it out. Root 3 times negative root 7 is negative root 21 plus positive root 21 minus 7. So again, what happens conveniently is that and that cancels out, leaving me with 3 root 3 minus 3 root 7 minus root 15 plus root 35. Again, if the root 15 or the root 35, if I was able to simplify those radicals, I would. Okay, but there's no perfect square that goes into that. So there's no like terms to the top. I can just leave the top like that. And on the bottom, I'm left with 3 minus 7, which is negative 4. Any questions on it? Okay, so in mathematics, we do not want to have a negative in the denominator. How can I get rid of that negative in the denominator? Okay. So what do you mean by invert? It means flip it. Okay, so if I have a negative number, and if I flip this, it'll still be the same fraction, the same value. Yeah, so you're telling me, so this right here, this and this mean the exact same thing? No. Okay. Anybody else feel? Exactly. Okay, bring the negative to the numerator. So remember, and this is another little aside, if I have a over negative b, the negative belongs to the fraction. So you can take that negative and you can move it to the top. And that's usually what we do, because when we're dealing with fractions, we're usually working with the numerator. Okay? Or you can write it like this. So that negative belongs to the fraction. You can put it with the bottom, you can put it with the top, or you can put it out in front. All three of these things mean the exact same thing. Okay? Now I'm going to do that with fearless said, which is totally right. I'm going to do it incorrectly, and then somebody's going to correct me. Here's my negative. So I brought my negative up, which is totally correct. My bottom is not negative anymore, which is good. What did I do wrong? Exactly. Okay, so remember that negative applies to all the terms inside of the bracket. Okay. So you can leave it like that, or if you want to, you can distribute the negative through. Okay, so in any of your work, and especially on tests, don't leave a negative in the denominator. Move it to the top. Any questions? Any other questions on radicals, rationalizing? Did I cover all that? Okay, so now we're going to move on to function notation, which is kind of funny in terms of you did this in grade 11, so we're going to review it. But then in guide 6, 7, we do this a lot. We do the same thing over again, but a little bit more in detail. Okay, so functions. Given the function f of x is equal to 4x minus 3, and the function g of x is equal to negative x squared plus 1, determine so then again, a lot of when teachers are teaching, they say things, they just assume that you know what I'm talking about. Okay, why are these functions? Does anybody remember that from grade 11? Even before I ask that, what type of, if I graph this thing, what will I get if I graph this guy right here? Yep. Right, it's a line, right? How about this one? What's that going to be? Parabola, okay? So, does anybody remember why lines and parabolas are functions? Right, they both pass the vertical line test. And basically what that's saying is if you put in a value for x, you're only going to get one answer for y. That's what makes something a function. Right? What's something that's not a function? We would have spent a lot of time in grade 10 working with these things. Yep. Right, circles. Okay, circles aren't functions because if you put in a value for x, you'll get the value for y on the top and the one on the bottom. Okay, so these are functions, right? And you can name functions anything you want. In math, we tend to use f and g and that a lot, but I can use a, b, c. Doesn't matter what it is. This is like this guy's name. Just like my name's Adam, this guy's name is f of x. Okay, same thing here. Okay, so what I want to do now is I want to determine the function at different values. So if I ask what is the f function when x is equal to 0, what does that mean? What is it asking me to do? Yep. Exactly. So this tells me which function to use. Here's my f of x. This tells me what I'm replacing x with. So I'm going to replace x with 0. And then I just use my bed mass, and I get my answer. This says, use the g function and evaluate it at -1. Okay, here's the g function. Everywhere I see an x, I'm going to replace it with the value -1. Two negatives make a positive, right? What am I forgetting to do? Right. Right, the exponent. And it's those little things that people tend to do on tests because they're going quickly. Okay? Just stop. All the tests in this class are designed to be about an hour long, and that gives you an extra 15 minutes. Okay? So take your time. -1 squared is 1. The negative's still up. Right? So -1 plus 1 is 0. So I can choose anything I want for x. I can say, evaluate what f at a is. So the same concept. Don't let letters confuse you. Exact same thing. This one said, put 0 in for x. This one's saying, put a in for x. So it becomes 4. Wherever I see an x, I replace it with a. That's the answer. Not much to it. That's all you can do. You can put anything you want there. So for example, I can put a binomial. Again, the g function, I want to figure out what the g function is when x is replaced with the binomial h plus 1. Okay. So here's my g function, -x squared plus 1. But instead of writing x, I'm going to write down what's inside of the bracket. So negative, instead of writing x, I need to write down what's inside of the bracket and put brackets around it whenever you do substitution. Square it, and add it to 1. Make sense? Same concept, I'm just taking something different and putting it into the x. Okay, so again, one of the most common mistakes people are going to make on tests is they're going to give me this answer right here. So that's h plus 1 squared. Why is it? Right, exactly. Okay. So remember that there's going to be that middle term, because h plus 1 squared means h plus 1 times h plus 1, which is really h squared plus 2h plus 1. And those are the type of things that are going to bring your marks down on tests. It's not your knowledge. It's you're going quickly and you're trying to rush. Okay. Distribute the negative through. Simplify. We'll get that as this. Any questions? Okay. Let's try simplifying an expression. Okay? So a rational expression, I should say. So this is a nice question, typical nice question you might see in a test that I'm testing your knowledge. So this is like that page in the guide, but then the guide, which I don't like, whoever made it up, but the guide has the answer beside it. Okay, so what you're trying to do is take this expression and simplify it. Okay, and in the guide you're trying to match it to the right-hand side. So this says take the g function and replace x with 2 plus h. So I'm going to do that. The g function was -x, but instead of writing x, I'm going to write 2 plus h. Square it and add it to 1. So that part here is this part. Minus, now I'm going to do this part, the g of 2. So that tells me to write down the g function, negative, replace x. Whenever you do that, make sure you put the second part in brackets. So that part is that. And then that whole thing was over h. So it's this expression you're trying to simplify. Does that make sense? Okay. So now it's just a matter of simplifying and using the skills that you brought to the class. If you're able to skip steps, feel free to do that. If you are still struggling in doing that, make sure you just write this out. 2 plus h times 2 plus h. One minus inside of the bracket here is negative 4 plus 1 over h, negative 4, negative 4h minus h squared plus 1. Negative 4 and 1 make negative 3. 2 negatives make positive, so it's plus over h. Collecting like terms in the top, I have negative 4 plus 1 plus 3. So negative 4 plus 1 plus 3 is 0. That. And I'm left with the rational expression, negative 4h minus h squared over h. So this is a rational expression. It has 3 terms, and each one of those terms has a what? Okay. H. So I can take out a factor of h out of each one of those terms. Okay? I can divide this term by h, I can divide this term by h, and this term by h, leaving me with negative 4 minus h over 1. So that's the final simplifier. Make sense? One of the most common mistakes people are going to make, again, on a test in simplifying rational expressions is I'll see something like this. And they're like, oh, there's an x on the top, x on the bottom. We'll cancel those out. Make sense? It does make sense. It shouldn't, because you can only ever divide through if all the terms have that x. This has an x, this has an x, this guy doesn't have an x, there's nothing you can do. Okay? If there was an x here, then you can cancel it. Okay? So please be aware you can only divide through if all the terms have what you're dividing through by. Any questions on the functions? Okay, I just want to do one of those fractions inside of the fraction questions. So on your learning guide, page A5, question B, I believe is this, correct me if I'm wrong. Anybody have that learning guide? Is that okay, so this is one of those kind of bed mass and kind of keeping things in order type questions. So this means 1 plus 1 divided by this expression over 1 plus divided by this expression. Okay? So this is really something called a composite function. It's a function inside of a function inside another function. You always want to start from the inside and work your way out. So what I'm going to do is I'm going to simplify this part. So to simplify that part, I'm taking a number and adding it to a fraction. Add fractions, I have to find a common denominator. The common denominator would be x minus 1. 1 plus 1 over 1 plus 1. So now I'm doing the blue part. Okay. So the common denominator is going to be x minus 1, so I need to multiply this 1 by x minus 1 on the top and on the bottom. So I get x minus 1 over x minus 1, that's that 1 right there, added to 1 over x minus 1. So now that I have a common denominator, I can add the fractions. So I get 1 plus 1 over 1 plus 1 over x minus 1 plus 1 would be x over x minus 1. So it's the negative 1 and the plus 1 will cancel out, right? And the denominator stays the same. Make sense? Okay. This is the part where people mess up on, right? So now I'm going to do the red part here. This means 1, because I had 1, divided by this fraction. So this means 1 divided by that. Okay? I'm just going to write it down. So really I'm doing this part in red here. It means 1 divided by. So that and that mean the exact same thing. It's just two different ways of writing. Do you think it would matter if I did 1 over x divided by x minus 1? Do you think that's going to change anything? Come on, take a guess. No, it will. That's why it's very important to make sure you understand which one was the fraction and which one was what you're dividing by. Okay? So I'm going to do this one, and then I'm going to do what I said here, and we'll compare the answers. So this is what I asked. Would it matter if I took 1 divided by this, or if I just choose this as the fraction and divided it by that? So the first one, when you divide fractions, you invert and multiply. So 1 times x minus 1 over x, which is that. That's the answer I'm looking for. If you mess it up and lose control of which one's a fraction, which one's the whole number, you're going to get the first fraction, invert the second one, and you're going to get that. So you have to be careful on which fractions you combine and what you're dividing by. Make sense? Okay. So I'll just continue on here. So this would have been 1 plus 1 over 1 plus, and I've got the red answer up here, so I'm just going to write that. Okay. So now I'm going to combine the blue part. So the blue part is 1 plus 1 over, find a common denominator, which is going to be x over x plus x minus 1 over x. One plus 1 over, adding the fractions, you would get 2x minus 1 over x. Again, right, it's 1 divided by 2x minus 1 over x. Okay? So 1 divided by, I'm just going to rewrite it for the benefit of the note. And once you get the hang of these, you'll be able just to invert and multiply it automatically. So this becomes 1 plus invert and multiply. Which is that.
Please excuse the interruption, but could all grade 11 classes please proceed to the auditorium now? That's all grade 11 classes. Please proceed to the auditorium now.
Now I'm down to the last adding of fractions. The common denominator will be 2x minus 1. So I need to multiply that to the top and the bottom of the 1 here. Add it to that fraction, and I get 3x minus 1 over 2x. So when you're doing these questions, really take your time, make sure you can add the denominators, common denominators, but at the point where you're dividing, make sure you know which one you're dividing by which fraction. Okay? That holds true for the rest of the course. Okay, so that's all I was going to cover for today. Tomorrow I'm going to cover the B part, and then next week, I think what I'm going to do is do a lesson on Monday, Tuesday, Wednesday for the rest of the guide. That way, Thursday will be kind of a work period. You can ask me questions, and then Friday is your first scheduled test day, and that's when Unit 1, 2 is going to be due. Okay? So does that seem fair to everybody? So tomorrow I should be able to hand you out the lesson schedule I was telling you about. Okay. Any other questions you want me to go over from Part A? Okay, so we're good. So what I'm going to do is, like I said, is I'm going to save this